welcome to another video of the TSA with Ed Supply. One of the things I want to talk about on this video is one of the most common things I get asked during the fall and during the winter time of the year is about our defrost boards. And I get a lot of service calls from some service techs that have called and said, hey, I've replaced this board 3 times. The unit still won't defrost, still having issues with it. And so we're going to break down this board and how it operates compared to our older board. We're going to cover both of those in this video. This will be a quick video, and hopefully it'll shed some light on this board so where you can understand how this board functions and operates. So if we look at this, our ICP part number is a 1193029. This particular defrost board is on all the N4H5Ss, the R4H5Ss condensing units, as well as our PHJ package units. And you'll see this on a few other boards as well, or a few other pieces of equipment as well. So it's one of the most common boards they have. So we're going to dive right into this and kind of break it down for you. All right, the first one we're going to start at where the arrow is pointing is on the Molex plug that comes up from the thermostat wire. So we call this the thermostat Molex plug connection. This supplies power to the board from the thermostat and the transformer, and it sends the signal by 24 volts to the contactor, reversing valve, defrost timer, and it's connected to the indoor unit and the thermostat. So these are the wires that are snapped in, that hang down, that when you run your thermostat wire out, this is the plug that you're going to run tie to with your wire nuts. So you got to make sure that this thing is snapped in all the way and it's secure. ICP usually will use orange for O, red for the R, white for the W2, yellow for the Y, and then a black for the common. And then sometimes I've seen them use brown on the common as well. So different ones will use different colors. Just make sure that C is color coordinated and is matching whatever you're tying it to that goes back to your thermostat. The next prong we're going to talk about is the Y terminal. Now this Y terminal, if you was to look on your board, and let's say you have your thermostat gives a call for the Y signal to come in, it goes in through the board and comes out this terminal here. So you'll have, when you have a call for 24 volts on your thermostat, this prong should also be hot, and you can test that through a common. Here on the side of that Molex plug to here, you should have 24 volts if the board is good. If the board is good, this will take 24 volts, and it's going to go through your low pressure switch, if you have one, and your high pressure switch, and then come back out of the board from there. So this signal is sending 24 volt signal going into your circuitry to make sure your low pressure and your high pressure switches are closed. Then it's going to come back on this plug here, the T1 plug. Now the older board did not have this prong, but this prong completes the daisy chain. So you're going to go a call from yellow coming in from your thermostat, goes into the board on this prong, comes out to this prong, goes into your low pressure, high pressure switches, comes back up and snaps here and sends that 24 volt signal from here, goes in through the board, and then will come up to this T2 connection that we have here, which completes the 24 volt call. So it goes in with Y, comes out of the board here, goes through the low and high pressure switches, comes back to this terminal, goes in through the board, and sends 24 volts up to this T2 terminal, which also powers up this relay, and this relay. Now this terminal here, you'll have a wire on this Molex plug, what I call our reversing valve or our defrost timer Molex plug. It will have a yellow wire with probably a blue stripe. This will go to the hot side of the contactor. Then you'll have a brown wire right here on the C, which is common. That goes to the other side of the contactor, and then that pulls the contactor in when you get a call from this signal. Now, this also, while this is pulled in and feeds 24 volts, this timer, as long as the contactor is pulled in, this is a defrost timer relay. This is your reversing valve relay, and this one is your auxiliary heat relay. So what happens, you'll get a 24-volt call, comes through Y, comes out of this board, through our low and high pressure switch, comes back to the T1 plug, comes out of T2, down to the contactor. Once this is completed, all these relays have power. So as long as your unit's running, this timer will have 24 volts, and the timer will run depending on what you have your defrost set at. So now we want to go down the board, and we're going to go to these speed up pins. Now here's what's changed from the old board to the new board. This new board speed up, you just have to take a flat regular screwdriver and short that out. Now I've seen people use a female terminal plug. So you can use that. You can use a flat piece of metal. You can use a screwdriver, whatever you can. Shorten it for 5 seconds. In 5 seconds, take your screwdriver off, and you will force the unit to go into defrost. And that's how you can actually test that those speed up pins are working and the defrost board is working, because there's some other things about this new board that we're going to talk about that the old board didn't have. So now we go to our defrost sensor, the DFT. That's your defrost thermostat. It's usually pink wires and has a 32 to 65 degree temperature plug on the other end that snaps to the coil. And ICP sets this at the first coil that frosts up when it goes into the heat mode. That's usually where you want to set it. You can experiment with it by all means. If you want to move it up a link or move it to another one to kind of let it run a little longer, a little less, that's totally up to you. But ICP puts this at the best location to where it gets the coldest first, and therefore that's where this thing is going to sense at 32 degrees. It'll start to shut and close, and it's going to send a timer up to 24-volt signal like we were talking about up to this relay. Then if you have it on 30 minutes, that relay starts counting down 30 minutes before it sends power to the reversing valve and reverses it into AC to start the defrost process. Okay, so keep that in mind. 32 degrees up to 65 degrees, it'll come out of defrost and switch all this back around. Now the next one, this is what is new on the board. This is our quiet shift and our defrost switch, our timer switch. So if we look at this, this is called the quiet shift. It's a blue plug. It lets you set, now you're going to see here 3 switches, SW1, SW2, and SW3. So SW1 and SW2 operate defrost. SW3 only operates quiet shift. It's either going to be off like it is in this picture, or if you flip it up, it'll be quiet shift will be on, and I'll explain how that works. So you have an option of 30, 60, 90, and 120. So here's how this works. If one is on, SW1 is on, this represents this 30 right here. And then SW2 is off, that represents that 30. That lets you know you're in 30 minutes with the quiet shift off. Looking at this picture, that is a 30-minute defrost set with the quiet shift off. Now, if I want to go to 60, I would pull this switch down, turn that switch up, and then you'll go into 60. And we'll break that down more into as this video goes on. But we have this SW1 and SW2. You can set it to 30, 60, 90, or 120-minute defrost cycles. So you see, if SW1 is on and SW2 is off, you're in 30 minutes. If SW1 is off and SW2 is on, you're in 60 minutes. And if SW1 is off and SW2 is off, you're in 90. If SW1 is on and SW2 is on, you're in 120. And then SW3 only operates the quiet shift. Now, in this is your diagram. Now, this is something I want to share real quick. Most of you that are not familiar with this is your go-to app if you are working with ICP equipment, whether you are a TempStar dealer or a day and night dealer or a Arco Air dealer or a Comfort Maker dealer, whatever the brand may be. If it's an ICP product, you need to download this app. It's called the Fast OEM Parts Mobile Tech. So it's Mobile Tech in your Apple Store and your Android store. Download this app because this is where I've got this diagram. So you can open up this app, continue as a guest. If you want to start an account, you can, but it works just fine if you continue as a guest. And then you can go up and you have different ways to actually look for items, whether it is searching by the barcode, like you can actually scan the barcode in. You can actually go through barcode, or you can do a let me get this right in a minute. You can actually go through and scan the barcode, or you can do a search engine, or you can type in the serial number. And in doing so, you will pull up the information on the piece of equipment you're working on. Now, let's say I'm searching for, let's say in this case, it was an N4H5S 60. I can put the N4H5S in, or I can search wiring diagram for the N4H5S, and this pulls this up. So if you're out in the field and you want to make sure that the unit is wired correctly, then this is where you're going to go for that. Now, one thing I have gotten calls in the past is if you're working on a unit that's several years old, you may not be the only tech, you may not be the first tech that's ever come to the property. So you want to make sure that the contact and the unit itself is wired up properly like it's supposed to. And I get this call quite a bit. So when you get to the unit, you can first start off and look with our outdoor fan 1 and outdoor fan 2. So you're going to have two wires, two black wires on this relay on your defrost board, and that is the condensing fan motor. So you have on outdoor fan switch 1, that's a black wire that comes up and it goes over to the top of the contactor. So only when the contactor is pulled in will power come through, and it turns that leg of the motor on. It's your hot leg. The other outdoor fan switch 2 is a black wire that goes up to the actual motor itself. So it's going to be the black common wire off the motor is going to come in and have your outdoor fan 2 switch goes there. Then you're going to look at, here's our Molex plug that hooks to our thermostat and our indoor unit. We have our defrost thermostat, that is the pink wire with the defrost sensor here. Then we have that Molex defrost plug, that's the T2 common. And so that yellow and blue, if you look, that yellow and blue wire we followed up is the hot side of the contactor. So remember what we was talking about, when the call for a W or a Y comes in, it goes into the board and it comes out the board on the Y terminal. It goes up and it's a yellow and pink wire. It goes through the low pressure switch, make sure that's made, and then it goes through the high pressure switch, comes back to the board to the T1 plug, goes into the board and comes out at the T2, which then goes to the contactor and pulls in the contacts, and then the motor comes on and runs. So understanding that and seeing this diagram, sometimes you can see it and you'll be able to know, make sure everything is wired exactly where it's supposed to be at, and you can get that information from this Fast Parts app. Now, when we talked about the quiet shift and we talked about the defrost, this is what you're going to find on the app, is this diagram right here, and this will show you SW1 on, SW2 off, you're in 30 minutes. SW1 off, SW2 on, you're in 60 minutes, which is default, which comes from the factory at 60 minutes. If I want to go to 90 minutes, I take SW1 and SW2 and turn them both off. That gives me 90 minutes. And if I want 120, I push SW1 on and SW2 on, and I'm at 120 minutes, and then my quiet shift comes off from default from the factory. Now, we talked about the new board. This new board, you can jumper the speed pins up, and it has, and I understand this is speed selectable options for initial time period between defrost cycles. I can speed up at the jumper the test pins, use a metal object, field speed up cycle, momentarily short pins and release to bypass compressor off delay, short for 5 seconds and release for forced defrost. Permanently shorted will be ignored. Defrost will terminate in 30 seconds if DFT is open. Defrost will terminate normally if DFT is closed. So if I'm above 32 degrees and I short this out, it's going to run in defrost for 30 seconds and then come out. If it is below 32 degrees and I force that speed up, it will put it in defrost and actually run through its cycle. Now we want to explain to you the quiet shift. What the quiet shift will do here is if I turn it on and the timer reaches our 30-minute mark and it says it's time to go into defrost, your outdoor unit shuts off for 1 minute, and then you'll hear the reversing valve switch over. 30 seconds later, it'll come back on and operate in cooling mode until the temperature, that thermostat sensor shuts off at 65 degrees, and then it will shut off for 1 minute. Reversing valve shift over, 30 seconds later, come back on in heat mode. And what it was made or designed to do was, if you think about this in the grand scheme of things, most condensing units are setting outside a bedroom window, and that's the only thing at night running. While we're sleeping, the only thing running is the outdoor unit. And you would hear this great loud swoosh of the defrost switching back and forth and waking homeowners up, and there was a lot of complaints. So instead of us setting the outdoor unit in front of the kitchen or underneath the kitchen window, they still leave it on the bedroom side of the house. So now they have quiet shift. You will never hear that swooshing sound in quiet shift. So that is kind of why they done it, and it's a little bit more efficient. Now, so here's our older board, and you can tell this is an older board because we only have the 1Y terminal coming off the board here, and we have this jumper wire here for an actual defrost timer. Now, this part number is 1173636. Now, you can use, let's say you have this board here, and it's the old board, and you're going to replace it with a new board to actually do the quiet shift. You can still do that. You will have to maybe add a wire for the T2 because you have to have that 24 volts coming back through. So you would have to add another wire if you do that, but it is definitely possible to do so. And so basically what you would do is take the wire that you're going to see is like a yellow wire coming off of this terminal here that goes to the contactor. If you have the new board, that plug that's up here, there will be a T2 that'll still go to the contactor, but the one that you have on it now, there's two wires on there. If you have this board here from the factory, there'll be two wires on the contactor. You'll take the other wire off the contactor and put it on the T1 terminal of the new board. This will be labeled T2 on the new board. So you can still use it. But this was the old one, and it didn't have quiet shift. So on the old board, this is kind of the same thing we looked at, same exact Molex plug that goes to your thermostat and your transformer. Then we go up to the T1 terminal, and this one is a T1 in common, so that's 24 volts has to be here, or this timer will not initiate and run, and your unit will never go into defrost. All right, and if you have 24 volts here, when it says it goes into defrost, this switches power and sends power right here to the reversing valve, which is the C and the O, goes to the reversing valve, switches it over into cooling mode, and then when the temperature here, that sensor senses it's above 60, it switches this back off, and then it comes back into heat mode. All right. So down here we have our speed up pin. Now the old board was set up a different, kind of a different way. You could short the board, the speed up pins out for 2 seconds, and you could test in a 10-minute defrost cycle to make sure the unit is actually working properly. Now, if you have this set here on 30, then you would short it out, and after 7 seconds, it would automatically kick into defrost, and you remove the short. It would stay in defrost until you pulled it out. Now, as this picture showed, we're in 60. So if I shorted this pin out, I would count to 14 before the actual defrost would start. And then if it was in 90, I would have to count to 21. and then it would go into start. And that's how you tested to make sure that it was sensing 30, 60, and 90 seconds or 90 minutes before it goes into defrost. And that's how you would test it, is by speed that out, doing your counting, and this was the formula they have for that board to test it. And then on this one, you had the Y terminal. This went straight to your low pressure, high pressure, come off the high pressure to the contactor, and then you had another wire on the contactor that went from there up here to this T1. So that would be the difference on the older boards, but basically the same. They just added another plug to complete the daisy chain and have one wire on the contactor, because it was getting so confusing that some of our units would have a solid yellow wire on the contactor and then a yellow wire with a stripe, and people were taking the yellow wire with a stripe, putting it on the common side, and then this right here never had 24 volts, so the unit was never going into defrost. So as we look here, the old board lets you select by jumper wire from 30, 60, and 90. So it would give you, once it went into that time and it sensed this, it would trigger W1, which is always running up here, up to this timer, and would kick it in and out of that. When this reversed over to cooling mode, this would send a signal down to here to tell it to hit for your heat strips to come on. Now here's the breakdown of the older board. Same way, you can go to the mobile app and you can pull in the information and put in what your model number is, or search wiring diagram, and you'll have the same thing here. So we want to kind of go over in this diagram. You can see that the OF1 wire goes from the outdoor fan relay to the top of the contactor on the black wire side, and the OF2 wire goes from the outdoor fan relay down to a black wire on the outdoor fan motor. Now our yellow terminal, the Y terminal, receives 24 volt call from the thermostat, comes out of the Y terminal and daisy chains through the low pressure and the high pressure, comes out of the contactor coil hot side. As long as the low pressure and high pressure are closed, the contactor will pull in. The orange wire on the T1 and C plug receives 24 volts from the T1 wire from the contactor, the common wire from the contactor, and then the two orange wires to the reversing valve. This gives the timer 24 volts when the contactor is pulled in, and will go into defrost after the desired time is set. Then we have our defrost sensor. The defrost sensor must be snapped in all the way. Once it reads 32 degrees, the board sends a signal to the T1 to start the timer for defrost. Once the timer is satisfied, the unit energizes the reversing valve and forced into defrost. And then, as you can see on this diagram of the old defrost board, the thermostat pigtail, the Molex plug, O goes to the reversing valve on the T1 plug, as well as the reversing valve solenoid. W2 goes to the auxiliary heat relay to send power back to the thermostat when the unit goes into defrost. R gets 24 volts and feeds the defrost board. Y goes out to the Y terminal. Daisy chains to the low and high pressure switches, and then contacts to the contacts. Then C completes the 24 volt circuit. It's very important to hook up your common. Don't rely on batteries. Once again, this is the mobile OEM Fast Part app. Make sure you download this app. It's a must-have app for ICP equipment. This app lets you not only find manuals, but also part breakdowns, as well as communicate with equipment using your near-field communication antenna on your cell phone. And that completes this video. This is part number on the defrost board 1193029, which is ICP's new quiet shift defrost board.